Good morning, everybody. Let me start by introducing quickly myself. My name is Heinz-Peter Beckemeyer, and I'm responsible at Texas Instruments as the Director for Automotive Systems. I'm based out of Germany, but we have this effort based on a worldwide scale. So we have a global effort here to address the automotive market. And let me update you today on the strategy of Texas Instruments inside the automotive market. We'll talk about design challenges automotive engineers have, and also how we are going to address and help those to ultimately accelerate the future of automotive systems. Before I do this, I would like to bring you a little bit closer to TI and where we are at. At first, Texas Instruments is a company which has a wide footprint of a product portfolio. We have a breadth of a product portfolio which goes across 100,000 analog and embedded processing products. And those are used by more than 100,000 of the world's most innovative companies. When you look at the market itself, Texas Instruments is basically present in the top markets ranging from industrial, where 33% of our business is coming out of the industrial market, personal electronics, 26%. We have enterprise systems, about 6%, and I think the communication part doesn't come through here, but that's the communication part. And we have the automotive business, which represents for us 18% of our total company business. Let me talk a little bit more about the strength of Texas Instruments with the breadth of the portfolio. When we look at any typical end equipment, whether this being on the automotive side, this could be on the industrial, this could be on the personal electronics side, a typical block diagram consists of a number of different functions and building block parts. We can see on this block diagram the typical real world is the sensing world. We have whether we want to detect temperature, ambient light, a radar sensor. This signal typically needs to be conditioned and needs to be processed into the digital domain and back into the analog domain. And from here, you need a connectivity which can be wireless, which can be a wired connectivity, and all of these components and the system needs to be powered, and obviously needs to be powered in an efficient manner as well. The strength of Texas Instruments is that in all of these areas, we are actually bringing a product portfolio to the table. And on top of the product portfolio, Texas Instruments is working on a comprehensive library of reference designs to help accelerate system designs, to accelerate engineers to faster develop their solutions and to solve their challenges which they are facing on a daily basis. Now let me dive a little bit deeper into our leadership into the automotive market. When you look at this chart, you can see at first that we as Texas Instruments, we released in 2016 2 times as many products compared to 2014. So there is a lot of effort, a lot of R&D investment into the automotive market. 22% of TI's R&D investments are in embedded analog and display technologies for automotive. And the one point which I mentioned before, the one point which is very important, Texas Instruments is inside the automotive market for more than 30 years, 35 years to be more precise, which means we are committed for a long time already in the automotive market. We bring a lot of expertise as well, and we bring the right level of commitment and the sense for quality level as well to the automotive market. When you look at our revenue, which we generated out of the automotive domain, automotive market, we can basically see the big success where we have driven our automotive revenue from 12% of the overall company's revenue in 2013 to 18% of revenue in 2016. You can see the commitment which we have paid here towards the automotive market is paying off accordingly. We have today more than 2,000 automotive qualified semiconductor products in our portfolio. And again, they range from the analog to the embedded processing to the DLP side to really deliver the breadth to build full systems as well here accordingly. To support and to accelerate the design effort of automotive engineers, we started a couple of years ago to work on reference designs. Those can be subsystem or system reference designs, which we will see throughout the presentation here today in numerous examples, which come actually with design, collateral, documentation, etc. We will today look at how we accelerate automotive systems, and you will see I will touch base on a couple of examples, but to start with as well, Texas Instruments is working on a global basis with the top car manufacturers and also the tier ones. This includes actually as well Korea, which is an important message. And our goal is ultimately to help developers, to help companies on the challenges to reduce vehicle weight, improving the efficiency across all vehicle types and systems. With our breadth of the portfolio, we provide as well the flexibility to design engineers to achieve their performance, to achieve price, to achieve design time requirements from entry level to premium vehicles. The design packages which I mentioned, or our reference designs, our subsystem system reference designs, they help make it easier for the developers to innovate and to reduce design time for applications which require standard certification or regulatory compliance. So let's dive into the details of the four growth areas and sectors inside the automotive market. Number one being ADAS, or Advanced Driver Assistance Systems. Number two, Body Electronics and Lighting. Number three, Infotainment and Cluster. And number four, Hybrid and Electric Vehicles. We will see in all of those what today the trends are, the challenges designers are facing, and also examples of how we are addressing to overcome those challenges. Before we go into the first sector, let's have a quick look at the number of vehicles which are actually produced on a worldwide basis. In 2016, we had more than 90 million vehicles produced. And on the right side, you can see as well the scale over the next years, and we will be way above the 100 million units vehicles by 2021 produced on a worldwide basis. Since all of the new systems being introduced, making the car as well smarter, more connected, and higher efficiency as well, we can see that the average semiconductor content in per vehicle, per car, is increasing from year to year. And in 2017, there is approximately $324 of semiconductor content per car. And this number will, over the next years, increase to about $361 in 2021. So it's a very steep rising semiconductor content, and therefore obviously a very important market for Texas Instruments. Okay. Now let's look into the first sector, the advanced driver assistance systems. And basically here, it's about we empower automotive developers to create advanced capabilities for the next generation of assistance and autonomous driving. And the evolution in the vehicle sensing, the intelligence and control for ADAS solutions is basically preparing us, is paving the way for autonomous vehicles, for autonomous driving. So moving from the trend to the challenges and the solutions. The challenges which are seen by automotive engineers, we are talking about unprecedented levels of automation. We require vehicles in the future to have the capabilities to detect complex driving environments. Developers will need to create systems that can distribute and also process immense volumes of sensor data in real time with unquestionable reliability. That's the biggest challenge once we have more camera information, more sensor data to come in and to process. How does TI overcome these challenges as well? We are preparing ourselves to have solutions for camera-based, and camera-based systems are like front cameras, rear cameras, surround view. Those can be mirror replacement or driver monitoring. Plus radar-based systems from blind spot warning, collision avoidance technologies, as well as sensor fusion and autonomous driving. So the challenge is basically the solution we can bring to the table, how to aggregate the data from cameras and sensors intelligently and reliably, as well for the evolution on to the next level on the autonomous driving. We also provide what's called our safety design packages, and they can help making it easier for ADAS designs to meet the regulatory functional safety requirements. And you will see on the next slide as well, we are coming up with innovative subsystem reference designs, which are kind of a jump start for engineers out there, where we can actually have the design collateral, we can have partially a turnkey solution as well for engineers to quickly evaluate and to get moving faster. Let's look at one example of an innovative subsystem reference design. And here on the next slide, we can actually see an example how we can easily connect cameras for an ADAS design. And again, as I mentioned before, there's an increasing need for multiple copies of aggregated video sensor data for machine vision, viewing, parallel data processing, and data logging. Now, this design, which you can see here, enables a developer to quickly test an environment where I have multiple cameras, and by the way, we have similarly camera reference designs as well in our library, where someone can actually take the camera reference designs plus this hub design to evaluate a system. This hub design, on the other hand, can be connected to our TDA processor side, where the full system environment can be validated and evaluated. And if you think about it, these are new challenges to the automotive market. We are talking about cameras which have a megapixel plus in terms of resolution, and we are talking here about data speeds which are in the 100 megabit or even into the gigabit per second range, which are new challenges in the automotive domain. Now here we see the PCB, the board. Let's move to the next slide where we can actually see the block diagram of this hub design. And here you can see the strength of Texas Instruments. To build up this subsystem of the hub design, you can actually look at the individual components here, and the full system can be designed by leveraging TI's breadth of the analog analog and embedded processing portfolio. You can see on the left side there are the 4 cameras, and again we have the similar reference designs on ti.com as well available, plus here the hub design, which is on our side a full TI solution. And again, this plays to the strength which we provide here in the automotive market. Let's move to the next sector, and we talk here about body electronics and lighting. Now, we are building here building blocks for body electronics and automotive lighting systems, which provide the convenience, comfort, and cost savings from bumper to bumper. And the number of applications inside body is fairly big. There are new end equipments being introduced as well. There is discontinuity a couple of years ago on the lighting side, where one moved from incandescent to the LED light. There are different type of new end equipments which are being introduced really from year to year. Let's look as well here at the trends, at challenges and solutions which we bring to the market. So on the trend side, there is more intelligence and control added to body electronic systems. An example is the including HMI, human-machine interface, gesturing, voice recognition, optical sensing. This might be for a backlight, this might be for mirrors and sunroofs, or backlit LED buttons and knobs. So there is a variety, there is a number of things which are being introduced in the body electronics and lighting sector. The challenge is to adapt as well quickly here, to quickly and easily evolve the systems to meet the changing features and requirements. And that's where we as Texas Instruments, we provide again a big help on the solution side. At first, with more than 30 years supporting automotive developers with a wide variety of design needs, TI continues to invest and innovate in the future of body electronics. We see today as well, we have investments where we are upgrading our portfolio. We have an example today, like on the CAN interface side, where we have a demo as well. We can look at, but still we are improving. We are enhancing our features. We are lowering EMI. We are improving EMI performance. So as such, we are working on the reliability as well for improvements on the body electronics and lighting side. And the building blocks, they enable developers really to evolve or build on existing systems here. And for us, it is important, to my point earlier, to continue to optimize body electronics, like the example we can look at, and also like, again, the reference designs which we bring to the table here. Okay. So let's look at one case actually where we developed the next generation solution where we can help on the efficiency side, on the space side for body electronics. One device which we would like to announce here today as well is what we call a multi-switch detection interface for body control modules. What does this multi-switch detection interface basically do? Inside a body control module, all the signals which come, like from the wiper, from the light switch, they need to be detected for the body control module to act, to turn on or off a load. Now, this device basically helps us to reduce the complexity of the system. We can, with this device, we can basically detect multiple switch inputs, and as such as well, we provide for this device as well the compatibility for high voltage signals which are connected like to the battery voltage. And the device itself is called the TIC 12400 and 10024. And we will see here on the next slide that we can reduce with this device 98% or the power dissipation by 98%. You might ask, how is this possible? Typically, to detect these input signals, you would have an MCU watching out and monitoring all of the input levels. Now, with this device itself, we can actually put the microcontroller into an idle mode while this device is checking these input signals. And in this way, the MSDI device is by far lower power consuming, and as such, we can enhance the efficiency of the system. And this, where we can have up to 54 signals, which we can detect here in this case. We will see later on as well a video about the device and the reference design itself, because with the release of the device itself, we immediately released as well a reference design for engineers to quickly jump onto the solution. All right. The other big trend, obviously, on the body electronics and lighting side is the lighting piece of it, whether it's being the interior or the exterior lighting on headlight or rear light. But vehicles are adopting more complex lighting systems, moving from static, incandescent, and HID bulbs towards dynamic LED illumination. And this is all to embrace more efficient, but also creative automotive lighting designs. That's clearly the trend which we are seeing. And there is a higher adoption rate as well to new technologies here. So the challenge for engineers in the automotive market, in the body electronics and lighting market here in particular, is to embrace innovation and creativity to rethink capabilities and designs for traditional automotive headlights and rear lights. Systems are today completely different compared to 10 years ago. And most likely they will be again completely different in 10 years from now. So there is clearly the need for embracing the innovation. And we can help there a lot. We have a number of automotive lighting solutions which enable engineers to quickly and easily design headlight and rear light subsystems for single LED or for multiple string LED solutions. There is a number of reference designs which we provide there for headlight, for the rear light applications. With the help of our products and the reference designs, we can actually improve the reliability, we can prevent overheating, and we can certainly extend the life of headlight and rear light LED systems. And we can do this by anticipating to overcome system design challenges through our legacy, but also through the innovation which comes in here on the lighting side. One example on the next slide where we show how to quickly improve the specification of a lighting system. And here it's all about the precision dimming which is needed for the intensity control of the light. An example could be a daytime running light on the left side, on the right side, and they need to stay within a certain boundary compared to each other. And typical analog solutions, they might make it challenging to stay within the certain precision. And we are helping with this type of TI design, which is based on building block devices from our side to get to a resolution which makes it actually good enough to be within the 2% duty cycle range. And we are improving here the system down from 20% down to 2% accuracy. And simply by analog circuitry design, which is based on our building block portfolio. And again, this can be a quick jump start for engineers who are facing this challenge and to quickly do the analog design architecture accordingly. The design collateral and everything is available for every engineer on ti.com. We move to the next sector, infotainment and cluster. And here it's all keeping drivers more informed and less distracted. And the trend here on the infotainment and cluster side is creating an, oops, I'm sorry, one click too much. Okay. Creating an interactive, connected experience through integrated entertainment, multimedia, and informational functions, and also to mimic a smartphone in a vehicle. And I think this is a fast-moving trend as well. Obviously, out of the consumer world, we want to get all of the benefits and features right away as well to be interoperable inside the vehicle. That's the trend. Obviously, there are alongside challenges as well, where we need to move large amount of data throughout the vehicle and data over longer ranges, and they not only require high performance processor power and capability, but it's also the connectivity with advanced features that enable security over a long distance. Our technology is designed to interact actually with complex infotainment and cluster systems. The important thing, maintaining the focus on the road. And hardware and software compatibility at the subsystem reference design maximizes the investment as well across multiple infotainment and cluster platform, and clearly reducing the time to market and lowers development cost. We are coming here as well on top with a reference design library to help and support engineers on the development side. One example of a fast-moving market as well and trend dynamic inside infotainment and cluster is what we call media interfaces. And we just know the USB Type-C out of the computer market, and already we as Texas Instruments, we are anticipating the needs for USB Type-C interfaces. Not only the part which is being on the market, which is released on the market, we are coming here as well with a reference design which actually covers the USB Type-C in head units. And the big challenge clearly for engineers out there is to move here as well quickly. A new standard on the computer market being adopted by the automotive industry. Now let's move to the fourth sector, which is also a very disruptive sector, where it's about hybrid electric vehicle and powertrain. And we as Texas Instruments, we are providing the building blocks which are needed to electrify and increase efficiency in automotive systems from the car to the grid. So the trend for sure is here seen in higher level of electrification inside the powertrain subsystems. Innovations in motor control started maybe already like in EPS, electronic power steering systems. There are more loads, higher power loads, which are moving to the electrical side as well, like water, oil pumps, or integrated starter generator. And that's a trend which is moving with a high speed as well forward. And all obviously to ultimately to offload the combustion engine and to increase the efficiency. That's the goal.
네, 그래서 이러한 그 전기화의 목적이라고 한다면은 그 컨버스천 엔진의 로드를 줄이고 그다음에 전기화를 촉진하는 게 되겠습니다.
So the challenge is how we can actually innovate. How we can innovate to decrease weight, to boost the efficiency, and to manage power with less cords, wires, and mechanical components. We as Texas Instruments, we are providing a lot of knowledge into this market as well. There are a lot of areas where we are benefiting from our industrial portfolio, which we developed already also like decades ago, and the experience which moves us faster in the automotive industry as well for HEV EV systems, whether it's on the motor drive side, on the grid side, on the higher power side as well. The technology can help developers safely to deliver power to EVs faster and assist in reducing likelihood of component failure, and also helping on the diagnostic side in advance of failures. And enable more efficient power conversion, replacing mechanical components, which results ultimately also in lighter vehicles and higher performance using less energy. Let me show you one example how we help accelerating again the future of automotive systems. One example being 48 volt battery voltage in cars. And we've had for decades, we've had the 12 volt battery, and now there is a big momentum on the 48 volt side. This is new to automotive design engineers as well. And suddenly there is the need for DC-DC converters between the 12 volt rail or the battery and the 48 volt battery. So we came up here with a reference design, which is a full bidirectional DC-DC converter for a 1248 volt automotive system. It's a 2 kilowatt system, and again where we can speed up and help engineers to getting quickly to where they need to be. The system as well is built on TI's product portfolio. And the most important key components here is like an LM5170, which is a multi-phase bidirectional current controller. And this one in particular designed and aimed at the 48 volt market. But also you can see it's the product reach from analog to embedded processing. The C2000 Piccolo microcontroller is actually a core component here as well in this design. What's happening here in the market is we are moving basically from the traditional combustion engine in the evolution to the EV to the next intermediate step, which is mild hybrid. And in this mild hybrid solution, there are the high power loads like an air conditioning, cooling fan, electric heater, water and fuel pump. The high power loads which are now powered off the 48 volt battery supply, and they are offloaded from the combustion engine to achieve a higher efficiency. Okay. All right. The final reference design which I would like to show is as well an example where we can quickly help engineers to overcome technical system challenges. And moving forward to the battery side, to high voltage systems, there is a different level again of new challenges to come for engineers. Suddenly we have to talk about high currents, about safety levels because of high voltages, where we need to introduce new safety levels, where we have to be able to measure a high precision of high currents as well. This is one example of it's a turnkey solution where you can measure up to plus minus 500 amps of current in a very accurate manner. We can go down to better than 0.2% of the full-scale range accuracy with this current sensing reference design.
네.
To summarize, Texas Instruments is very committed to the automotive market. We have more than 30 years, 35 years of history in the automotive market, starting in the early days on the passive safety side. Today, we have a big focus in all of these four mentioned sectors to drive innovative solutions, to provide the right technical tools, reference designs for automotive engineers to accelerate the future of automotive systems. And this with the breadth of the portfolio ranging from analog to the embedded processing to the DLP side. And as you have seen in multiple examples, for most of the applications out there in the automotive domain, we are a key player where we can provide almost a full bill of material to any of these systems. That's the summary for the presentation. I would like to thank you. And